Get this ready. Cool. Well, hello everyone. It's Javi, and today I want to show some really cool things I've been working on over the past week, mainly regarding to AI. So first of all, we've already demonstrated this on Twitter, but OpenSource Observer now has an MCP server. But what is an MCP server? So basically, MCP is a protocol, it means Model Context Protocol, which allows people to, well, sorry, not people, allows AIs to connect with external sources. For example, imagine that I have an AI like Claude, and I wanted to, I don't know, search the web, or I want to interact with my database, or I want to buy stuff on Amazon. There are tools to do this, and the MCP enables like a common interface for all AIs to interact with these external services. So how does it work? So basically, our OSO MCP server basically exposes some tools which allow it to list table, execute queries, and do some analysis on it. So it's pretty cool because now my cloud is supercharged and it has like these tools as get table schema, get sample queries, query OSO. And if I paste that a query like, hey, I want to show the 10 projects in open source servers, project B1 table, what this will do is it will actually use one of the tools that we now expose, and it will execute this cycle using PyOSO. So basically, PyOSO, well, as everyone knows, is our API client in Python, and MCP is done in Python as well. So as you can see, this means that Cloud now is able to get access to like our up-to-date information. And this is like a really simple example because like I'm asking for some data, but in the future we want to like allow these AIs to do like complex analysis and be able to like detect some trends or do more interesting analysis. This is like a really nice first step towards that, and it actually enables a lot of cool features, which leads me to the second thing that I wanted to show you. Turn here. So let me share my screen. Something else.
So, quick question on this
Yes.
MCP server. Like, I noticed in the tools implementation right now, you know, like, sorry, just to screen share real quick. Hey, good to see you, James. No worries. If I go to Warehouse OSO MCP, in the main file, there's like, yeah, just a few tools, right? There's querying OSO, there's getting table schemas, there's getting sample queries, and a help guide. That's pretty much it. There's like 4 tools, right? Given your experience playing with this so far, what tools are missing? Like, how do we get it to answer higher value questions?
Yeah, so as you have said, these are like the really simple tools, which allows like an AI to say, like, to be aware of like the tables that are in our data lake or how are they composed. But one really big factor that I think it's like hindering these capabilities is the fact that we don't have an easy way to show like all the description. It's missing a lot of context. What does this column mean? Why is it here? Why is it not in another table? We need to give it way more context because the way that it's doing it now, it's like querying, for example, I don't know, models v0, where we have like all the sources for the schemas, which is inefficient because like the AI has to like query 500 tables, do an analysis of it, check. So I think that the first step would be to give it way more context and write, you know, for example, are you familiar with like the LLM's TXT file that it's like being now put in like all of these websites? It's like basically like a huge dump in Markdown for like AIs to like consume a lot of examples without having you to copy. We need to give it that context, first of all. So I think that would enable a way more interesting comparisons and analysis. And after that, it kind of depends because like the limiting factor is the AI itself. Like until what point can the AI, you know, infer what it has to do or like do all of these like transformations? We could help it by writing like how do you say this? Like more specific tools. For example, you want to do a deep dive into table A, use this tool which does these predefined things and like maybe sanitizes the data a little bit or lets you know some ways to like actually use these tables. If we want like more complex analysis, we'll have to help the AI because like I think that for the moment it's not ready to, you know, do all the heavy lifting itself. But yeah, I think that in the future we want to see a hybrid approach where we say we give some like direction and it should like figure everything out.
Okay, yeah, I think I was more asking specifically if you had any ideas of specific tools that you think we're missing that would give it the context.
We definitely need a tool which exposes what each column for each table is and has like a small description about like why is the table there? Why do we care about, I don't know, commits daily and why not, biweekly? Like we need to like tell the AI why we have like our structure so that it calls that tool with like all of the context and it's able to like effectively choose, because the only context that now it has is like, okay, there's a table commits monthly. There's a table called artifacts. What's an artifact? How can it know what's an artifact and what's like a collection? What's the difference? So we need to like give it that context. I think that would be like a first step. Yeah.
Cool. Awesome. No, this is awesome step in the right direction.
Which means that this MCP server enables really cool functionality, because now we can connect virtually any AI to open source web server, and it doesn't have to be Claude. It can be, for example, Google Gemini, which leads us to the second thing I want to show, which is our new AI Studio V2. So for the moment, it is only this route. There's nothing like I'm missing the number here, but let me show you how it works. So basically here you have like a place to do a query, which has all these things that highlights. For example, I want to, I don't know, show catalogs, and this is connected only to like the, how do I say this? This is connected to my Docker Trino. So the catalogs are different, which means that the example that I will show will need some tweaking, but in production it would work. And it has some cool things, like you can, for example, format everything, or you can, you can put some example queries and you can format them. So this is how we do it. But this is not the killer feature. The killer feature is that this small button that we have here, which enables us with our own AI assistant. So basically here, this is connected to Gemini, to Google AI Studio. I'm using now, I think it's 2.0 Flash, which is cheap, and it's a pretty hot model. It's the one that's being used a lot. And we can ask a lot of things because it is actually enabled with MCP. So I can say, for example, this query says, I want to find the project which received the most commits last month. What SQL query can I use in the OSO data lake that uses a table which exposes commits monthly? We hit run, and it does this thing. The thing is that the Flash model is a cheap model, so it actually made up the table. But if I see something like list me all tables which expose commit information in the open source observer data lake, this will use the MCP tools under the hood. And as you can see, it basically gives us all the information from all of our tables. How about the schema for the table? I don't know, this one. And with this, the person who's using our AI Studio actually has more context and is able to have, a buddy, a pair programmer with him, which has access to like the up-to-date data and is using their API key under the hood. So this is like built to the currently logged in client. What I want to achieve with this in the end is that you have like a tool that allows you to introspect our tables and our schemas, and craft high quality SQL queries so that the person can, for example, come here and say, I don't know, list, create me a query which lists 10 items, 10 commits from the yearly collection table. And that should, what I want to do is like, come here, copy this one, paste it, run it, boom. This won't work, as I said before, because I'm using the Trino Docker, which has like different schemas and everything. It's a dev version, so not all the data is there. It's a small subset. But this is basically how it works. And webpass select. This is how it works. And I'm pretty happy with how it actually was. But if you have any question, please let me know.
Cool. I'm curious, where do you feel like you struggle the most with hallucinations?
With sorry, what?
Hallucinations, like incorrect column names and table names and whatnot.
Yes. So the thing is that the model I'm using is like a Flash one, so it's like pretty cheap, and it doesn't have a lot of context windows. So, which means that if I'm like talking in the conversation, it won't actually like recall back messages. It's like a really like simple first iteration. So that would help in the future. But I think that the AI prefers to actually invent a table instead of using our tool. So when I say, hey, I want to get, for example, the commits collections yearly, instead of like saying, okay, it's open source server table, let me list everything, which table I want, it like makes one up. I think that this is because like it's a cheap model. We can test, for example, with like Gemini, like a pro version, and it would most likely, actually query it. But yeah, well, Carl joined just now, so we have like an AI studio. Yeah, I think that we need to find a balance, because I understand that we cannot evidently use the best models, but the gap between a Flash model and a Pro model is abysmal, and the quality as well is abysmal. I've been trying with like really cheap models from Google, and they don't work all the time. So it's a really hard question, because we need as well to consider our billing strategy, everything. If we use a Pro model, we can maybe give 10 queries, which is like really limited. If it's like a Pro, yeah. There's a lot of pieces into work.
Let me ask a question there. Let's have you tried running it with the most expensive model?
I have not, but we can test it right now. Let's test it in live stream.
Yeah, feel free to. I don't think that's the right answer, in my opinion. From what I've read so far, like, yes, you can expect it to maybe probabilistically provide slightly like better answers on average, but I don't think that's the only thing that you can do, because ultimately you can't prevent that 100% of the time that you're not going to get hallucination. So I don't think like, okay, throwing the most expensive model all the time everywhere is the right way to solve this. Like,
yeah,
I think this is where the eval framework like makes more sense. Like, you might get better performance with a cheap model doing the cheap thing multiple times with an LLM as a judge to tell it whether or not it's moving in the right direction. I think the other cheap thing that we do need to be doing better of, like you said earlier, is like giving it better context and understanding of like what tables are valid, what columns are valid, like the better context and prompts that we give it. I don't think we should expect just like that, having a more expensive model will actually solve some of these more fundamental problems.
Yeah, it's even struggling right now. So the main problem that we have is that we cannot control when the AI will use our tool. We can give it a hint like, hey, I want it from the open source server data lake. But at the end of the day, we cannot tell it to just use it. I mean, maybe like we can give it some context in the back end, but in the end, like, for example, this one would probably work. But it tried, 2 times, and it failed 2 times prior with a super simple query. So I think that we have to do like, well, let me share the code so we can see how it works under the hood. Window.
Sorry, was that you were just running it with the more expensive model just now?
Yeah, that was the most expensive one. I tried twice before, like, saying, okay, let me try again. So how this works basically is we have like, I'm using Versus AI SDK. We have here like some system context. Here's where we want to add, when we want to add all of the context. This is like a pretty small, context window. But ideally, he will say, okay, you need to use like the open source server MCP tools as much as possible. If you're unsure of like an answer, do not like make it up. This is just like a super simple, system prompt that I did. But at the end of the day, how this works is we have like here the AI studio, we get all of the data, we fetch the chat route, we stream everything back, and then we have like some components for like the editor itself, which has all the completions, and the open source server chat, which is the floating one. On the right, I agree with you, Ray. Throwing the most expensive model is not the solution. I think that we have to, in the system prompt, more aggressively tell it to actually use our tools where possible. And yeah, I mean, the thing is that, LLMs are not deterministic. So there's always like that, risk that it just hallucinates. So yeah, we'll have to try to make it the best we can.
Which route is it right now that's actually like
this
doing
one.
the combination? Oh, okay, got it.
Yep.
Okay, so everything is in that API route, right? That's
That
actually
is
in our
correct.
LM. And then
Mhm.
everything on the front end is static? Like,
Yes.
okay, cool.
Yes.
Great. So, yeah, you just explicitly define a protocol between static client-side components and the API service.
Correct. Yes. And
Okay,
here
great.
we also use.
I like that. That's clean. Maybe if feel free, like you have access to my calendar, feel free to schedule like a half an hour probably is enough for us to walk through how to merge the remaining stuff. Because yeah, there's a few things that I'm seeing from this that are super cool that I would love to get in. One is any of the React components that we want to bring into the front end. Like, yeah, I'll show you how to import into Plasmic. That's super easy. The second of which is we should probably come up with a better approach to how to do like remote MCP. So let's talk about that and like where we want to throw that in Kubernetes. And then like how do we want to abstract out like which models we're using in prod and things like that. But yeah, this is awesome. This is a great start. You can already see like where this is going, right? I think this is like super powerful.
Yeah, I'm pretty proud of this one. I think that I'm pretty happy with like the UI, everything. It's like pretty clean. Like I would use this, like if the model was like, didn't hallucinate and I had to do some OSO queries, like I would actually use this.
Yeah, I know. I just feel like there's like there's the vision of like what people think you can do, and then there's like the 1 week version of this, which is what you did, which is great, which is it you can see the UX, but it really doesn't, it's not going to work right now. It's going to be like quite a bit of refining to get to the 99th percentile where you can actually service 99% of queries from a unsophisticated non-developer, interacting with it with like high quality results. It's going to be like a while till we get there, but this is definitely the right first step.
First iteration, we just got to continue trying, continue experimenting, and of course, we'll get something cool in the future.
Awesome. Sweet.
Cool.
Yeah, please schedule some time with me later today or tomorrow. I'm happy to work through this.
Of course. That's everything on my end. Does anyone have any questions, any feature requests, something? Yeah.
Yeah, the one thing is, I think what we should talk about when we meet is there's a bunch of things that Reuven and I are doing in Python land. And then there's a bunch of things that you're doing here right now in React land. And there is a common core, which is like there's something between prompts, model selection, parameters, eval, and like architecture, like workflow architecture, that you probably want to share as much as possible. And then because that is where you're going to get some semblance of quality, like quality answers that we'll have to like coalesce on. And like we're setting up some eval infrastructure right now that we're going to want to incorporate in this as well. And then hopefully, the front end is just like a thin layer, right, to communicate with that. So yeah, let's chat about that next time. But definitely we're a step in the right direction.
Of course, perfect. Thank you.
Sweet. Anyone else have questions? Sorry, didn't mean to commandeer.
No worries.
Let me show Reuven stuff next because I think it's also really relevant to this. Reuven can't make it right now because he's sleeping in Japan.
So yeah, I just posted on the team chat.
Can you guys hear any of that, or is that?
Yep.
You can hear it? Oh, wow. Cool. All right. Right on, Google.
Not feeling so great today, so I am going to record just some stuff that we have for the demo. So the first thing, probably the most interesting that we're able to do this week, we disabled the soft deletes after doing some cost. So hopefully this looks okay for the cost cutting. So I guess we can just take a look at this bad boy. And then, yeah, so one of the things that, I guess it is hopefully not the worst. Let's find out what we've been doing. this. Select this. Yeah. All right. So it's steadily been going down, which is good. Obviously, yesterday we had some stuff for the compute engine, but cloud storage is now at a much more reasonable rate. I'm guessing that is maybe the more steady state value here. Huh. But yeah, so we remove the soft delete. This is just something to note anytime you make a cloud storage bucket. The buckets themselves, by default, they have soft delete turned on, and this is a problem for our exchange, like our fault tolerant exchange mechanism that we have turned on for Trino, because it uses that as an ephemeral storage area. So yeah, so that's just one thing to note. I have some ideas on maybe how we can make that even cheaper in the future, just because it is only an ephemeral thing and just needs like high write throughput. So we might be able to use like maybe a locally hosted kind of S3 like thing to do that in the future. And then yeah, the next thing is just looking at Arise, which is pretty neat. This is so as we can see here, I have right here in this window I have the MCP running, I have Arise running. You can run Arise simply by using Docker. Oop, I just killed Arise. I documented this actually, and then when you run this in the agent, I'm not going to wait for the second thing to finish because I know it's pretty slow in my machine. I'm running Olama. Oh, hey, yeah, answered that, I believe, correctly. But yeah, you can take a look at the trace, which is pretty incredible, actually. You'll see, like, the thought process it goes through, kind of the some of the system contexts, everything that is going on in here. Like, this is the cool part, you see, hey, you have these tools, you can see what they are. So we see a trace of really everything that is going on within the LLM. And so, yeah, this is insanely useful. I've been messing around with some other things, kind of thinking through how this is all going to work. And some of the other stuff that we did, there I was able to do this sprint was just getting helping do some debugging. One of the other things that we accomplished this past sprint was getting every single one of the SQL mesh models now has some kind of audit, and I believe this is helping. Yeah, it's this that we can see right here. So let's hope that that's true. And I'm running out of time on this loom, so hopefully this is good.
Yeah, so there's two follow-ups from there that are probably most relevant for Carl and Evan. One is, I should file an issue on this, but Carl and Evan, I would love to start a spreadsheet on like a diversity of questions that you would ask the LLM. Like easy questions, medium difficulty questions, really difficult questions. Easy questions would be like, just show me the commits for this project, right? Like medium level questions would be something like, maybe some comparisons, maybe like, between these two projects, maybe like, which are the things that are growing the most in the ecosystem, these types of like one stage of reasoning type questions. And then the hardest questions would be like the most abstract strategic questions, right? Things like, what the transactions seem to be falling, what do we think is going on? Or like high level types of like reasoning and analysis. But we're going to need a list of these questions sooner rather than later. The way that Arise is going to work is you're going to want to have a set of benchmark questions that you're asking it constantly, right? And then over time, the agent's going to evolve. Right now, the agent is a really simple wrapper for an LLM, really dumb, right? Eventually, it's going to start. Eventually, we're going to move in the not too distant future into a multi-agent framework. even with a multi-agent framework, you're going to be doing things that like, you know, you're going to be giving it different context. You're going to give it the ability to, you know, search the web. You're going to give it the ability to do different things. And over time, as we make these changes, we're going to want to see how it performs against these like our own benchmark, right? It's basically a benchmark of like how it performs against different types of questions over time. Hopefully it's getting better, but I think as we start to reach the edge, we'll start to see like, okay, these changes like make deep, you know, analysis type queries way better, but at the expense of like reliable performance in the easier queries or vice versa. And so I think the sooner we can start to measure these things more methodically, the easier we're going to have a better chance at like knowing that we're making improvements over time. So I'll file an issue for this, but like a Google spreadsheet of like representative questions that you might get from Jonas or Lizzie or someone from leadership is like super valuable. The other thing I would say is, yeah, SQL Meshland, I think we should get into a better habit of writing audits. I know Reuven went over this really quickly in the video, but do you guys have a better sense of, do you have a good reasonable sense of like what audits are and how to best to use them when we're writing SQL mesh models? If not, I can roughly show you what we've done so far with a little bit more detail.
Are you directing that at anyone in particular? Like
just anyone that's writing SQL mesh models, like yeah, probably good habit to start writing audits.
Yeah, I mean, I think that Evan and Rohit don't need to unlearn anything because they're in the process of learning it for the first time right now. And yeah, I've been following along. Makes sense to me. I have a whole bunch of tests that I do locally. I think it seems like we're going to not use tests. We're going to use audits going forward, right?
No, I definitely wouldn't say that.
Okay.
They both
Every
exist.
every model should have an audit then, and then tests we can do additionally as needed.
Yeah, that sounds right. So yeah, audits are more like checking if things fall outside the norm. Like if a number should never be negative, like we should have an audit to check in production if it happens to go negative or something like that, right? Or if it should always be within some range. Those are good things for audits. With the audit that we're doing right now, like, you know, models should never be empty, right? If we're writing an empty model, then something's gone wrong, right? So things like that are audits. Tests would be something like, yeah, you know, there's like logic things that you want to make sure that you are implementing correctly, right? So a good example of tests would, like we've shown before, is like, yeah, like when we're doing like URL parsing to split out the namespace stuff, like making sure that we implemented that correctly, and make sure that we don't accidentally introduce bugs when we change the implementation of how we do parsing. Like that's where unit tests make a lot of sense, but audits is more data level as opposed to logic level. But yeah, I think we should build that muscle. It's like super valuable because it's the only thing we have right now, since we don't have data diffing capabilities. The least we can do is make sure that the data falls within some reasonable invariance. Cool. I guess super related to that, Ikaro's not here, so I can just roughly show the stuff that he's been working on. So if you haven't played with this yet, we need to add this into the doc still. But in the SQL Mesh directory, I think this README is up to date. We got rid of all the OSO initialize stuff, which I think was blocking you previously, Rohit. So hopefully this is no longer a blocker for you. No more need to initialize. All you need to do, if you have a new data source, you can kind of see the new data sources here under, nope, sorry, am I in the right place? Metrics tools, seed, schemas. So you'll see in here, we create fake data when we're testing and developing, yada, yada, yada. We hard code fake data in here for you to test against. So that's why you don't need to initialize anymore. So we're actually just hard coding it. So might be worth looking into if you ever have data sources that change for some reason. This might be one reason why, is that like you got to make sure that the seed data actually is the right schema. But since it's hard coded in the code base, you don't need to initialize anymore. You can just go straight to, so UV sync would basically just install your dependencies and then go straight to running. So this replaces our old DuckDB thing. You now run SQL mesh -test with the --duckdb to run things on DuckDB, and it should just work. If it doesn't work, then there's a bug, and please let us know in Discord. And then so that's the way to run it against DuckDB, and the way to run it against Trino is here. So I would use the local Trino with Docker Compose. You got to make sure you have Docker Compose installed, but assuming that you do, then you can just run it like this. And I would, if you're making changes to models, I would definitely try to run it against both DuckDB and Trino. We want to maintain compatibility with both. But so before you push to main, definitely do these. We also run it in CI/CD just in case you miss something, but that's not flawless, as we noticed last week when I pushed a bug. So please run it yourself. Like, don't not run it yourself. And assuming CI/CD will catch everything for you. So anyway, yeah, that's new and exciting. Hopefully that unblocks you, Rohit. Please let us know if it doesn't. The other thing that this is super invisible and no one's ever even going to notice this, but this is like a huge win for us, was Icaro pushed a change that allowed us to do branching. So basically what this does, and this doesn't change at all how you interact with it. You can still go to Dagster and just run the SQL Mesh All Assets job. You should be able to safely run that now. That's here. Where is it? SQL Mesh All Assets. You should be able to see that we ran it safely a few times recently. Where is it? All Assets here. Run yesterday at 11:30. So yeah, that seems to be running now. We had this corruption. We still have this corruption bug. We still don't know what's causing it. But while we are debugging it, we have some safety mechanisms in play. So basically, when we run SQL Mesh now, it runs in a totally separate branch, completely separate from the main production branch, or they call them SQL Mesh environments. And then only if it succeeds do we merge it in. So that just gives us a level of safety that was way better than before. So this is super useful. I think we're definitely unblocked now to start running stuff. Hopefully, Carl, you're fully unblocked there. Yeah. And then the only other thing I was going to share on my end is we've basically, I think, fully removed all of our dependencies on dbt BigQuery now. The deps.dev was the last staging model we needed to move over, and that seems to be running okay. Hasn't failed yet. Seems to be okay. So if people are, unless there's objections on this call, I'm going to go ahead and start deleting stuff from BigQuery. We're probably still going to support Javi, you have this BigQuery exporter, right? So Trino, correct. I'm going to change it so that it exports to the OSO dataset instead of the metrics dataset. But that's it. Like, we're not actually running pipelines in BigQuery anymore. We're just like storing a copy of the data in case people want access to it through that way. Which is probably the as far as I know, that Dot doesn't have any integrations for Trino and stuff like that. So we'll probably have to use that.
Nice.
Cool.
All right, should I go?
Yeah, please.
Awesome. So the past 2 weeks, I don't think I touched SQL Mesh more than once or twice, just doing some debugging, which was great. I spent a lot of time using PyOSO and onboarding some new people to use PyOSO. Let me start with some tutorials, which are intended to help new users get up and running in PyOSO in 5 minutes or less. And my benchmark for this is Jonas, and he was able to get everything going literally in a few minutes. No questions asked, everything worked, which is great because he's not very technical. So that was a big win. And he also said, as we think about LLMs, that he was able to kind of drop what he wanted to do in a query and give ChatGPT some clues, and he was getting stuff back that worked when he dropped it into OSO. Which is also nice because right now there isn't much logging that you get back from PyOSO when something fails, but it was working. Let me just run through. So we have in the tutorial section, there's like 5 or 6 tutorials that exist right now. These are ones that we used to support. Over the past couple of weeks, I refactored all the ones that we had to take advantage of PyOSO and the new GraphQL API that we have, because some of the models that we used to refer to no longer exist there. I also updated our Colab notebook, so if people wanted to use PyOSO in Colab, they could, although my guess is that the users who are going to want that is much smaller now, that there isn't data on BigQuery. And then as people have made requests for data, each time I've created a notebook, dropped it into the Insights repo, and have pointed people towards it so that they can see our logic. And ultimately, what I'm trying to show every chance I get is how easy it is to compose what would ordinarily be like very complicated nested logic in PyOSO queries. And I'll give a few examples of that now. So first off, let's do the quick start tutorial. I'm just going to run through this right now. I think it's a good way of getting an overview of all the things that exist. When I'm starting a new notebook, I will often just fork this and then modify things once I get going. But let me just run it now. If you're new, you'll have to pip install PyOSO. I've already done that. You can come in, drop your API key in your environment so that you can get it here. One helper function that I use all the time is basically just a way of taking a list and stringifying it so that you can drop it into a query. So the first thing that I typically show people is how to get all of the models that exist. So Javi, this is going into the models v0. And there you can see all the different models that we have. Actually, well, I think there's like 600 or so models that come back. So it's a pretty large set. We can think about ways of making this a bit easier for people to like search and discover. But this is a good starting point for people to see what's there. If you just want to look at the version models that are stable, you can use the v1 postfix. And so we have 8 or so models that are 7 models that fit that criterion. And then if you want to get some of the unstable models that we're still kind of actively working on, you can get those with the v0 postfix. And what's also useful is seeing the last time this rendered. So I ran this just now, and it's still saying April 1st. Does that make sense? Is that what it should be? I guess whenever there's a change, this would update, right?
Yeah, but we need to run as well, like the SQL mesh for that to like change. So
yeah, the rendered at is a question. I think that, what is that timestamp associated with? That timestamp is associated when was the last time we ran the source asset, right?
Yeah, that's basically a now for like the models v0 time. Yeah.
Okay. And then, yeah, here's some examples of querying things from popular models we can get, and we can see how fast these things are. It's pretty quick. This is looking at projects. Again, we have data from OP Atlas as well as from OSS directory. That's working nicely. If you want to look up OSO, we can find ourselves here. And then if you want to get all of the artifacts that we own, this is a bigger table, a little bit slower, but you can see all of those. And then we'll wait for that to run. Okay, great, there it is. Good reminder that we actually need to add PyOSO to our file, so people can see that there. And then finally, if you want to look at some of the metrics models definitely take longer to query. Actually, that was pretty fast. Key metrics is pretty quick. The time series one does take longer. So you can come in, you can see all the different metrics that are available for OSO. If we wanted to, oh yeah, this is fun. We can look at the comparison of projects here. So if you want to compare OSO to Hugging Face and Webm on Forks and Stars, that's what this would look like. And then, yeah, you could get all the time series metrics, and you could plot that if you wanted. Actually, well, I ran this earlier. So this is our star count cumulatively over the past year and a half. It's been pretty linearly increasing. So that's the first one. Again, people have been able to follow this, no questions asked, get through it pretty quickly. I won't go through all the other tutorials, but you can see that there's some other common use cases, like looking at a collection and coming in and getting, things like all of the commits for every project in the collection. We also have the GraphQL implementation if people want to connect it to their web app. And the other thing I'll show, so another thing that we did is updated some of the guides here. So there are quick guides for people getting started with Colab. This is how you do it. Jupyter, which is basically what I was showing just now. And then there's also a guide for doing it in Hex. So one notebook actually that's useful and potentially for work that I might ask Evan to help with is creating a Hex notebook. And last week we were contacted by the Ethereum Foundation, and they asked if we could give them a sense of what the developer ecosystem looks like for everybody who's building on Ethereum. And so that was a good opportunity to very, very quickly put something together with PyOSO. Let me just show you the dashboard that we sent over to them. The thing I want to stress here is not like how beautiful this is or what the chart says, more that this was maybe 25 minutes to actually get everything running, and then maybe another half an hour or so of just like making it look decent. So the point is that in 1 hour, you could do something that would take the people at the developer report, I don't know, probably weeks to do. So I thought it was a good way of showing off the capabilities of PyOSO. But yeah, here's basically a list of all the Ethereum dependencies, projects, repos, developers. You can see the change over the last month. Here's kind of a version of the kind of rate of change metrics, which kind of look at developer retention over time. Here, this is a simple version just saying, was it the first time they made any contribution in the ecosystem, or was it the last time? And then if it isn't either of those two cases, then we'll just assume it's a regular contribution. So you can see across the 2,000 or so projects that are in the set, things have kind of stabled out around 3,000, 3,500 developers for the past year or so. Another thing we can look at is just like how old repos are, how long they've been around. As you can see, things peaking around 2023 or so. Yeah, Ray?
How are you defining last contribution, especially if it's recent? Wouldn't we always expect?
Yeah, I chopped off the last 2 months, so it only goes until February. But yeah, otherwise all this would be red.
But yeah, okay, got it. So February, March, you would expect the whole thing to be red.
Yeah.
And the fact that, I mean, like, this is a little misleading, right? Because it just means that, like, some people maybe haven't been active since January, but if they are active in May, anyway. So it's basically, we should always expect this graph to date for it to go to dramatically turn into red based on
yeah, exactly. Like, obviously, if I extended this to April, it would be all red because that would be the last month for anyone, right?
Well, this just looks way worse than it needs to then.
I thought well, the reason I prepared this was because people were showing versions of this, which was it was dropping off a cliff. And I said, no, it's not dropping off a cliff. Here's what you can actually see. So it looked a lot better than what was out there. In any case, I think the cooler graph is actually this one over here, which probably nobody else would care about, which is, of all those projects, what do they depend on? What does their dependency set look like? Again, just a few lines of code. You can pull up all of the dependencies of every project that's building on Ethereum. And then here's a way of kind of looking up a project and seeing all of its usage by different projects. This is actually a little bit slow, but we could do, let's see, anybody have a favorite library they want to put in here? Actually, I was just on the call with the ZK Sync people, so let's look at ZK Sync. Ethers is one of the things that they maintain. This will take a little bit. Hex is kind of slow. But there it is. It's loading.
Is this what is this Hex notebook connected to right now? Is it still connected to BigQuery?
Good question. I'll show you in a second. Okay, there we go. 147 projects, 300 repos. You can get some stats on all those repos, and get a sense for, is that number growing and stuff like that. All this looks pretty good, I guess. Popular tool. Oh, sorry. Yeah, it would just be down here. We don't have like an updated version of this. It would just be this. So yeah, that's the dependencies view. To get to your question, Ray, it's using PyOSO. So here's kind of the logic that I have that works for Hex, which is basically if you're kind of in a kernel that's already active, then you don't need to install PyOSO. If you're not, then you do actually have to reinstall PyOSO, and that will take some time. And then we'll also have to execute the queries. So some of these queries are actually fairly slow to execute. So because of that, I basically dumped a backup as a CSV so that it can be a bit snappier. And then there's a setting where you can do a full refresh if you want to grab the latest data.
Cool.
Yep. But the main thing is each of these queries is like tiny, right? Like getting all the repositories, very simple. Even like the complex dependency graph is literally just, I don't know, 15 lines of code or something. And then the graph that shows all of the contributors across anything in Ethereum, again, it's tiny. It's like 20 lines, nothing very complicated here. And if you wanted to, you could fork this and do the same thing for Solana, which I also did just because I was curious. And that took about 2 minutes. So the point is not, again, to say this is like the best notebook ever. It's more just to say it's super, super easy for people to make cool notebooks like this.
Wait,
from PyOSO.
we're indexing Solana data?
What's that?
We're indexing Solana data?
Not on-chain data, but we have all the
Okay.
ecosystems data.
Okay,
Yeah,
cool.
you didn't notice that the cloud bill's going up?
Well, technically, I mean, that was like, that is probably the best use case for blockchain ETL, is like all the non-EVM chains they have pretty good support for.
Interesting.
And so Solana is a BigQuery public data set. And so you can do some interesting stuff with that.
All right.
I don't know that we are ready for it yet. But
One day. The last thing, just because we have a minute or so, Rohit and I were just on a call with ZK Sync and also using it as a chance to show off some things you can do with PyOSO. I won't give names, but there's another entity which put together a very long post doing all of this TVL analysis. And I kind of looked at the protocols that they cared about. And in like an hour before the call, basically put together my own versions of the graphs that they were paywalling, which basically show here is the delta between a project that received a grant on the state and all the TVL and all the other chains. And it's literally, that's it. It's like 6 lines of code. And there's a lot of like graphing logic here, but basically you can see, which I think is the case for all these incentive programs, when do you think the tokens were given out? Early January. When do you think the supply dried up? 2 months later. And here you go. So you can see that here. It was pretty cool to see like consistently those data.
Hey, Carl, not sharing the screen for what you're referring to.
What's that? Oh, sorry, I'm not doing my tab. Whoops, wrong thing. Yeah, so here's the demo that we gave. Here's the query to get all of the TVL data. Again, it's like 7 lines. And Evan, I'm sure you can appreciate how difficult it was to get this the first time around. But you can literally come in. This is all you need. So much more of it is actually making the chart look nice. But then you get these graphs here, which I think are actually pretty cool. So you can see here is when the incentive program started, at the beginning of January. You can see the TVL jump up for a short period of time. This has all been normalized. So that's like equivalent to 14 million at its peak. And you can see what their TVL was like in all the other chains. So it actually stayed pretty flat. There was definitely an impact that happened just on ZK Sync. But then if you go to the end of the incentive period, it basically just drops off and in some cases goes below what the baseline was. Again, Point is just to say this was super, super easy to do. And then for the developers, again, I just took the same kind of graph I showed for Ethereum and just pulled anyone who's using the zkThink ethers. And then I looked up the GitHub full-time developers monthly on that. Super simple. Like the hard thing is just getting the join statements right, which will be good things for us to test together, Javi. Like, can it actually make those joins correctly? And then this isn't, it looks pretty, but it's actually not very useful. But you can see basically a stacked area chart of all of the developers that are using zkSync ethers over the past couple of years or so and how that's going up. So yeah, that's it. A few fun use cases of PyOSO.
Yeah. And this is like before you joined the call, during stand-up, Evan was asking, like, how does this all fit together, right? And the best word that I have for it is acceleration. Like, velocity is how quickly can we move now, but how, like, what are the accelerators, right? What are things that we can do such that the thing that took you months can now take a couple weeks, and in the future should take you less than an hour. Like a lot of this, I think this is why we've been pushing so hard on getting more things into SQL Mesh, is that the more it's embodied in a generic way, the easier these things become in the future.
Yeah, that was actually the point of what we were showing, is that you're just kind of swapping out one thing. Instead of using DeFi Llama as the source, use GitHub as the source, and boom, you can get the same type of things tied to the same project. And ordinarily that work is very hard. Like that was stuff that took us literally months to map previously.
Awesome. Fruit of our labor.
Yes.
Finally paying off. Awesome. For what it's worth, super, or anybody else have questions for Carl? Anyone that's interested in the fruit of our labor, this blog post actually is doing pretty well on Twitter right now. It got reshared by the CEO of Daxter and the CEO of DLT, nice. Just as like public use cases for what they're doing. I think the data space loves what we do because there's not very many examples of people doing this fully open source. Like most data pipelines are fully proprietary. So the fact that you can like literally point and link to the source code where it uses DLT or Daxter or whatever, it's like great marketing for them. So yeah, if you're interested in, for folks that are interested in understanding how all of it's put together in the back end, you can see why we moved away from a simple indexer, like how most people in the industry work, and how we've moved towards this more sophisticated data backend, data pipeline.
Ray, are you viewing that locally?
Sharing what?
Are you viewing that locally?
Viewing what locally?
The docs?
Oh, wait, was it not sharing?
You were. Yeah, but they don't look that way for me.
What doesn't look that way?
I don't know, like the font is different, and I know. I was just wondering if you were like testing a version that made some stylistic changes. Or this is
no. This is on prod. Yeah. Might be a Linux thing.
The same as Ray. Like for me, it's the same. Which browser are you using?
Chrome on Linux.
I'm using Safari on Mac. So yeah.
But you see the same font as what Ray had there?
Yeah, yeah. I mean, can you put it again? Ray?
Yeah, I don't. It's more sans serif and Arial like for me.
Yeah, that's what I'm getting too.
I'm on Chrome on Mac. It's crazy.
Ray, could you drop the link to that blog post actually in the chat?
Yeah, I'll do that now.
There you go.
Oh, thanks, Javi. Perfect.
No worries.
Oh yeah, my font does look different as well.
But yeah, we're getting retweets, and from the Hasura folks. I've complained about Hasura enough in public that they start following what I'm writing now, so that's good. Cool. All right. Well, upwards and onwards. I think this is just like a bit of a teaser of like where we're going. I can see in a couple sprints this becoming much more sophisticated, much more powerful. I mean, I don't care how we do it, like whether it's through an open source agent that we're building right now in public, or we use like Dot or some other equivalent proprietary service or whatever. But like, that's the challenge that I have for you guys, Carl and Evan, is like, and Rohit, is what is it going to take for us to be able to service any ecosystem in like, I don't know, ambitiously, like less than an hour.
Yeah, we're close. Yeah. And I was running some dashboards for the stylus program for the first time ever, and Carl shared some feedback, and just iterating on that feedback was quick enough using BioSO. So yeah, it's looking awesome.
Oh, do you have a version you want to share, or I don't want to put you on the spot? It was pretty cool what you had on Friday.
Oh, not yet. I think your feedback makes it better. So I'll share it. I'll drop it tomorrow once I'm able to pull in the additional views.
Okay.
Gotta jump to another meeting, but it's good seeing you guys.
All
Ciao,
right.
ciao.
Ciao, ciao.
Good night.